welcome Dr. Pete Worden.
Good afternoon. I'm truly honored to be here today and a bit humbled by the other speakers, particularly Professor Hawking. What I'd like to do today is talk to you a little bit about the breakthrough prizes and the breakthrough initiatives, which Professor Hawking gave a very good summary of. First of all, I'd like to discuss the breakthrough prize. This was a prize started in 2012 by Yuri Milner, a Russian national and Silicon Valley entrepreneur, to celebrate the accomplishments of our best scientists. The prizes consist of a $3 million prize. There's an initial prize was in fundamental physics. We now have 5 additional prizes in life sciences and a prize in mathematics. In addition, we have $100,000 prizes for early career scientists, and we just began a prize for young people, for high school students, a junior breakthrough prize. But I'd like to spend the bulk of my time today to talk about the breakthrough initiatives. The initiatives were announced on July 20th, 2015 at the Royal Society in London by Professor Hawking and Yuri Milner. Now the prizes are around these fundamental questions. Is there other life in the universe? Can we travel between the stars? And is there intelligent life elsewhere? The first initiative I want to talk about was Breakthrough Watch. We announced this just this year on January 9th in Santiago, Chile. And this is designed to find out, is there life elsewhere? Well, the first question, is there life in our solar system? Well, other than Earth, the most likely place that scientists have considered life is on the planet Mars. So far, we haven't found any life, although we believe that the conditions were right on Mars billions of years ago, that there was water and the other things may be necessary for life. But to date, nothing has been found, although there is a belief that in the water that's underneath the surface, we might find life. Now, perhaps the most interesting place in our solar system to find life is one of the inner moons of the planet Saturn, called Enceladus. The Cassini mission, which just completed a very impressive scientific mission 2 months ago, discovered that from the south pole of this moon, there are streams of water flowing into space. This is very, very interesting. It indicates that underneath a surface of ice, there is a huge ocean. But in these water plumes, that we found some very interesting things with the Cassini mission. We found that there's hydrogen, molecular hydrogen, a source of energy. Maybe more interesting, we found some carbon molecules, very simple carbon molecules, organic molecules. So this may be indication of life. One of the breakthrough initiatives is looking at, can we in the next few years send a mission here to look to see if there really is life. But probably the most interesting place to look for is the nearby stars, is to see if we can find a planet that might be life-bearing. Well, the nearest star system is the Alpha Centauri system. It's only visible in the southern hemisphere. It's easy to see. If you travel south of the equator, you'll see it as the second brightest star in the sky. But the interesting thing about this star system is there's actually 3 stars in the system. There's 2 of them that are more or less like our sun. One of them, Alpha Centauri A, is a little bigger. One of them, Alpha Centauri B, is a little smaller. They orbit each other in about 70-year periods. And then there's a very small star called a red dwarf star. It's maybe only 10 or 20% the size of the sun, but only 1,000th or so of the brightness. So this is the nearest star system. Well, interestingly, just last year, in August of 2016, the European Southern Observatory announced that they had discovered evidence, now not directly imaging, but evidence of a planet orbiting this 3rd star called Proxima. They named the planet Proxima b, that is orbiting the star in what's called the habitable zone. Moreover, the planet is just about the same size of the Earth. So this may be the nearest Earth-like planet. Now, we don't know very much about it. although interestingly they have an artist's conception of it, so I guess we don't need to go there, but actually we do. This is a very exciting possibility that there are planets nearby that are like the Earth. In order to look in more detail, we would like to directly see these planets. So we began a program last year with the European Southern Observatory with their giant telescopes in Chile. This is at the Paranal Observatory in Chile, to see if we could actually directly image the planets orbiting Alpha Centauri A or Alpha Centauri B. It's a very exciting program. We may be able to discover in the next 5 or 10 years not only planets like the Earth, but to see if they are life-bearing. Now, perhaps to me the most exciting project is Breakthrough Starshot. This was an effort announced on April 12th, 2016, which was the 55th anniversary of Yuri Gagarin's flight into space, an effort to see if we could actually travel to Alpha Centauri. It was announced in New York City at the top of the New World Trade Center, again by Professor Hawking and Yuri Milner, our principal sponsor. This is a truly impressive and exciting effort, and I'm really honored to be able to lead it. Now, of course, the question many years ago was, are there other solar systems? Are there other planets? This has been a very significant question. When I went to graduate school way back in the last century, we thought maybe only 1 in 1,000 stars had planets. But a very interesting mission that NASA mounted and launched in 2009 was the Kepler mission. I had the honor of leading the center where this mission was done. And what it did is it looked at 150,000 stars that were like the sun. And we looked and see very precisely, we could measure the brightness, the light from these stars, and we were looking to see for a very small shadow of a planet passing in front of the star. This was an incredibly successful mission. It discovered that essentially every star in our galaxy has a solar system like ours. Now, a quarter of them appear to have a planet that's about the size of the Earth, orbiting in an orbit like the Earth, where there could be liquid water on the surface. So this was a very exciting piece of evidence. More recently, a similar experiment looked at a nearby red dwarf star system. Remember, I talked about Proxima Centauri as a red dwarf star. Over 70% of the stars in the galaxy are these small little stars. This star was shown to have 7 planets that are about the size of the Earth, 3 of which are in the habitable zone. We now believe perhaps the most numerous type of planet in our galaxy are planets like the Earth, many of which orbit in the habitable zone. Now, the question is, can we go there? This is the Voyager probe. It's the most distant probe that humans have sent out into the galaxy. It was launched over 30 years ago. It's traveling faster than anything else that we've done. It's 130 times further away from the sun than we are. Now, would this be able to get to the nearest star? It's not aimed in the right direction, but if it was, the answer was yes. But it would take about 80,000 years, probably not likely to be funded by anybody. The nearest star is 300,000 times further away than the sun, the Alpha Centauri system. Well, the question is, can we go faster? We need to go 1,000 times faster than we can do today in order to get to the nearest star in about 20 years. Well, I note that in the middle of the 20th century, we did increase our speed about a factor of 1,000. So the question is, can we do that again? Can we go 1,000 times faster? This is the equivalent of Moore's law for electronics, that every few years can we increase our speed by a factor of 2, just as the electronics increase. Well, the first question is, can we use rocket fuel? Well, the answer is yes. We could put together a rocket that could get to maybe 20% the speed of light, which is where we'd like to go to get to the nearest star in 20 years, except if you calculate the amount of fuel needed is the mass of the galaxy. So we're probably not going to do that. But the question is, there's other ways to propel rockets. One is to use a nuclear power. Well, this is very interesting. about 3 years ago, when we thought about our project, we put a study team together under Professor Avi Loeb, the chairman of the astronomy department at Harvard, and he looked at nuclear power, but it turns out it doesn't work yet. Maybe in a century it will. So we looked at other approaches. We went back to a very, very old idea, sailing. And the interesting thing about sailing is you don't carry your energy with you. You either get it from the environment or keep it behind. So the question is, can we sail in space? Now this is a very, very old question. Johannes Kepler in 1610 actually wrote a letter to Galileo, another famous scientist of the era, suggesting that we could sail on heavenly winds in space, and with that some could venture into that great vastness. Now we're not quite sure what Kepler had in mind, but we think we have an idea now how to do it. The idea of sailing with light, that light itself will bounce off the sail and provide a motive force, it was suggested a long time ago, most significantly by Robert Forward, a scientist in the 1960s. This has now been shown to work. This is a Planetary Society mission of a few years ago that furled a solar sail and used the sunlight to push it. More recently, the Japanese had a space probe, the Icarus probe, that used light. The trouble is that sunlight is too weak. So the question is, can we come up with a more powerful way to push spacecraft? And the answer is yes. And there are two trends that we looked at that make this feasible. The first is that we're able to build things much smaller and build much smaller spacecraft. The second is we're able to use lasers to build much more intense light beams than we were with just using the sun. So the idea is that we could put together an incredibly powerful laser array. This would be huge. It would be 1 kilometer square. It would put out between 50 and 100 billion watts of power for a few minutes. This does appear to be feasible, and largely because of the progress made in communications, using lasers for communications. Now the second question, how about spacecraft? This is a typical spacecraft. This is a communication spacecraft. It weighs several thousand kilograms. Over the last decade and a half, though, we've been able to make smaller spacecraft. They're called CubeSats, that weigh only about 1 kilogram. Now the question is, can we go even smaller? I note that if you have an Apple Watch or a similar watch, there's an electronic chip in that watch. That chip actually does most of the things a spacecraft does. It has a camera to take pictures, it does computations, it stores data, it can measure its orientation and so forth. So our question is, can we build a spacecraft out of this technology, something we would call a star chip? And the answer is very definitely yes. Indeed, I brought one with me. This is a first-generation star chip, less than 1 centimeter in diameter. This has all of the functions and capabilities of a spacecraft that we could potentially send to the Alpha Centauri system. This is a major breakthrough in the technology that humans have developed. Indeed, just a few months ago, we launched an earlier version of this on Latvia's first satellite, and it was launched on an Indian booster, and it worked perfectly. This technology is coming along very, very well. So we think that we will have in hand in the next decade or two the technology to actually begin to go to the nearest star. And what we would do is connect this star chip to a light sail, would power it with a laser beam of 50 to 100 billion watts for a few minutes, accelerate it to 20% the speed of light, directed it toward the Alpha Centauri system. It would fly a little over 20 years, fly by, and signal back the data it would take with a small laser on board. Maybe, if all goes well, sometime a little after the middle of the century, we'll have our first picture of another planet that may be life-bearing orbiting the nearest star. Well, the final project that we did is answering, or is going to try to answer the question, is there intelligent life elsewhere? This is called Breakthrough Listen. It was begun on the same time we announced the initiatives, July 20th, 2015. And what we have done here is we have a much more comprehensive survey that's ever been made before if we can find signals that aliens may be sending to us or sending for their own purposes. What we did is we got time on some of the world's largest radio and optical telescopes. We started with the Green Bank 100-meter steerable antenna in West Virginia in the USA. Because we can only see half of the sky from there, we have 25% of the time on the Parkes radio telescope in Australia, the second largest steered antenna in the world. We also have begun to look for optical signals, recognizing that we communicate with lasers as we might from our star chip at Alpha Centauri. So we're using the automated planet finder at Lick Observatory in California in the United States. We've also worked with other groups. We signed an agreement just about a year ago with the National Astronomical Observatory of China to use this telescope. This is the FAST telescope, the 500-meter, the world's largest radio telescope. This is our best chance to maybe find an alien signal. We also signed agreements with the British Jodrell Bank telescope, and we're about to sign an agreement with the South African square kilometer array. When this is finished in 15 or 20 years, it'll be the equivalent of a kilometer square telescope. Impressive instruments indeed. Now I'd like to show some of the results. This is Professor Loeb, who chairs our advisory committee on Starshot. He proposed about 8 months ago that there's this phenomenon we see with these radio telescopes called fast radio burst. He suggested that maybe these were actually not a natural phenomenon, but produced by aliens trying to push spacecraft with radio waves, much as we were talking about with Starshot. The idea is that they may surround their star, collect the energy, and use it to push a spacecraft, even a very large one, that could even be a colonization ship between stars. We did try to observe this phenomenon. We detected much better data than anybody had before. Indeed, it turns out not to be aliens. It's probably a natural phenomenon, but a very, very interesting question. If all goes well, we will observe 1 million nearest stars, 100 of the nearest galaxies, and look for signals that could be evidence of aliens. So far, as I said, we haven't found any, but the project is going very well. So I think this century we may answer these fundamental questions. Is there life elsewhere? Can we go there? And is there intelligence elsewhere? Thank you very much.